Hello, this is another video for class 12 Intext questions of page number 21 and 22 for class 12th chemistry, first chapter solid states. Let's begin with the first question. That is the 14th Intext question. What is the two-dimensional coordination number of a molecule in square closed packed layer? Let us first elaborate the term coordination number. The number of nearest neighbors of a sphere in an arrangement is termed as coordination number. That means the number of spheres which are in contact with a particular sphere in an arrangement is known as the coordination number. In this particular one-dimensional arrangement, you can see that each sphere is in contact with two other spheres, one in the left and one in the right. This is a linear structure where only two spheres are in contact with the central sphere, hence the coordination number is 2. Similarly, in this figure you can see that each sphere here is in contact with 6 other neighboring spheres. So here the coordination number is 6. Similarly, in square closed packed layer, as it is asked in the question, the coordination number is 4. This is because the central sphere or any of the sphere we can consider, we are free to choose any of the sphere. So the sphere is in contact with 4 other neighboring spheres and hence the coordination number here is 4. The square closed packed layer is formed by putting one-dimensional line on other and so on. So you must not, it is just a simple structure as shown in this figure. One more thing, here spheres represent atoms, molecules, or collectively we can say the constituent particles. I hope the answer is clear. The answer is 4 here since the coordination number is 4. Now let's move to the next question. It is, a compound forms hexagonal closed packed structure. What is the total number of voids in 0.5 mole of it? How many of these are tetrahedral voids? Here it is asked that we have a hexagonal closed packed structure. We have to find out the number of voids as well as the number of tetrahedral voids in separate. You must not get confused with this structure. Hexagonal closed packed structure, it is only given to confuse you. Here is no use of it. The only formula which is used here is that the total number of constituent particles is equal to the number of octahedral voids. Hence we can find out the octahedral voids only if we know the number of constituent particles that are the atoms or molecules. So here what is given? It is given that we have 0.5 mole of a compound, the given compound. We have only 0.5 mole of the compound. So we have to use our brain with this given condition to find out the number of voids. See, we know that 1 mole has 6.022 into 10 raised to the power 23 molecules, collectively constituent particles, that means atoms or molecules. We can calculate from this formula that the number of constituent particles present in 0.5 mole will be half of number of particles present in 1 mole, and the number of constituent particles present in 1 mole is 6.022 into 10 raised to the power 23. Hence, the number of constituent particles present in 0.5 mole of the compound will be 3.011 into 10 raised to the power 23. So, this is the number of constituent particles which are present in the given compound. Now we know that the number of constituent particles of a compound is equal to the number of octahedral voids. So, the same number is the number of octahedral voids. That means 3.011 into 10 raised to the power 23 octahedral voids are present. Also, we know that the number of tetrahedral voids is twice the number of constituent particles or twice the number of octahedral voids. So, the number will be 3.011 into 10 raised to the power 23 multiplied by 2. That is again the same number, Avogadro number, 6.022 into 10 raised to the power 23. Also in this question we have to find the total number of voids. That means tetrahedral voids plus octahedral voids. So the sum will be 6.022 into 10 raised to the power 23 for tetrahedral voids and 3.011 into 10 raised to the power 23 for octahedral voids. So we have to add these both terms. So the answer will be 9.033 into 10 raised to the power 23. So this is our first answer, and for the second question, that is how many of these are tetrahedral voids, the answer will be 6.022 into 10 raised to the power 23. I hope both these questions are clear. Let us now move to the next question. Question number 16. A compound is formed by two elements M and N. The element N forms CCP and atoms of M occupy 1/3 of tetrahedral voids. What is the formula of the compound? Let us first analyze the question. We are given with two elements M and N. Also the locations where these elements reside is given, that is M is located on the lattice site and N is in the tetrahedral void. The thing which we have to find is the formula of the compound. Let us find out the general criteria of solving such questions in which two elements are given, their locations are given, and the formula of compound is to be found. The only thing to remember here is that the formula of a compound is equal to the ratio of number of atoms which forms the CCP, or the structure which is given here, it is CCP, and the number of tetrahedral voids which are occupied. Let us now solve this question. First we have to assume that the number of atoms which forms the CCP is A. By saying that, we can also understand that the total number of octahedral voids which are present in this structure is A, since the number of octahedral voids is always equal to the number of atoms which forms the structure. Okay. Also we know it from the text that the number of tetrahedral voids present in a structure is always equal to twice the number of octahedral voids present in that particular structure. That means we can now understand that the total number of tetrahedral voids present is 2A. Keep in mind that 2A is the number of tetrahedral voids present, the total number of tetrahedral voids which are present in the structure. But we have to find out the number of tetrahedral voids which are occupied. Then only we can find out the ratio. That is very easy to find. We know that total number of tetrahedral voids present is 2A and occupied are 1/3. So we have to find out 1/3 part of 2A. I hope you are getting it. It's an easy maths. Okay, so 2A when divided by 3, we get 2A upon 3. Hence the total number of tetrahedral voids occupied is 2A upon 3. The last thing is we have to find out the ratio of M and N. This ratio will be our required formula of the compound. So let us divide 2A upon 3 by A. A was the number of atoms which forms the CCP and 2A upon 3 is the number of tetrahedral voids which are occupied. So the answer will be 2 by 3. Hence the formula is M2N3. By solving one or two similar type question, you can get a clear idea of solving this question just by looking at them. We must now move to the next question. Which of the following lattices has the highest packing efficiency? Simple cubic, body-centered cubic, hexagonal close-packed lattice. So here we are asked about the highest packing efficiency. That means in which of these lattices we can pack more number of spheres so that the free space can be reduced to minimum. Hence the question is asking in which of these lattices we can fill more and more number of spheres. We already know the method of finding out the packing efficiencies of different lattice structures, so we are not going to do it again. We must know that the packing efficiency of simple cubic lattice is 52.4, that of body-centered cubic lattice is 68, and that of hexagonal close-packed lattice is 74. Hence, clearly the highest packing efficiency is of hexagonal close packed lattice. That means we can fill more and more number of pairs in this lattice as compared to the other two. Let's move to the next question. An element with molar mass 2.7 into 10 raised to the power minus 2 kg per mole forms a cubic unit cell with edge length 405 picometer. If its density is 2.7 into 10 raised to the power 3 kg cube, what is the nature of the cubic unit cell? It seems to be a tough question, but actually it is an easy one. We just have to put these values in the density formula which we have read in the explanation videos. It is, you can see, D is equal to Zm divided by A cube and Na. Here D is the density of unit cell, A is the age of unit cell, M is the molar mass, Z is the number of atoms present in one unit cell, and Na is the Avogadro's number. Here we have the density of unit cell, the edge length, that is 405 into 10 raised to the power minus 12 meter when converted into meter from picometer, molar mass, and the Avogadro's number. So let us alter this formula to find out the nature of cubic unit cell. Here we have to find out Z, number of atoms in the unit cell. By putting the values and by solving it, we will find that the number of atoms per unit cell, that is Z, is 4.004, that is approx 4. You must be aware of the structure which carries 4 atoms per unit cell. From here you can understand that face-centered cubic unit cell is the one which carries 4 atoms per unit cell. It is also called CCP as cubic close packed structure. Hence the answer is FCC and CCP. That means the nature of cubic unit cell which has the given amount of respective quantities is FCC and CCP. That is face-centered cubic and cubic close packed. I hope the answer is clear. Thank you.